Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll evaluate these three limits. Let's start with the first limit. Limit n approaches infinity, negative 1 over 4 to the power n. In this expression, the exponent n applies to both the negative sign and 1 over 4. We should analyze the behavior of this expression as n approaches infinity. As we increase the value of n, the value of this expression approaches 0. We can find that out by analyzing this expression. If n is equal to 1, the value of this expression is negative 1 over 4 or negative 0.25. If I sub in n as 2, I get positive 1 over 16, which is equal to 0.0625. If I sub in n as 3, I get negative 1 over 64, which is equal to negative 0.015625. As per this analysis, as the value of n increases and approaches infinity, the value of the expression negative 1 over 4 to the power n approaches 0. The absolute value keeps getting smaller. Therefore, the value of this limit is equal to 0. This is a very important concept we need to understand and memorize to evaluate this type of limit. Now we can evaluate the second limit. Limit n approaches infinity, n over n squared plus 1. This expression is a rational expression because it is made up of a polynomial expression in the numerator and a polynomial expression in the denominator. The degree of the polynomial expression in the numerator is 1. The degree of the polynomial expression in the denominator is 2. Degree 2 is higher than degree 1. We have to evaluate the limit n approaches infinity. So we can simplify this expression by multiplying both the numerator and the denominator by 1 over n squared, because the higher degree is 2 in this expression. In the numerator, n times 1 over n squared is equal to 1 over n. In the denominator, we can distribute 1 over n squared into the parentheses. We should multiply both terms in the parentheses by 1 over n squared. N squared times 1 over n squared is equal to 1. And 1 times 1 over n squared is equal to 1 over n squared. Next, we can use the algebraic laws of limits to apply limit to each term in this expression. In the numerator, limit n approaches infinity for 1 over n is equal to 0, because as n approaches infinity, the value of 1 over n approaches 0. There's a very important concept we need to understand and memorize. In the denominator, 1 is a constant, so the limit value is 1. We can break down 1 over n squared as 1 over n times 1 over n. Next, we can apply the limit to both fractions in the denominator. As we discussed earlier, limit n approaches infinity for 1 over n is equal to 0 because as n approaches infinity, 1 over n approaches 0. 0 times 0 is 0. I get 0 as the value of the second limit. Now we can evaluate the third limit. Limit n approaches infinity, negative 1 to the power n minus 1 times n. This expression is made up of two types of functions. The first one is the exponential function with the base negative 1 and the exponent n minus 1. And the second function is the polynomial function n. This expression is the product of these two functions. Next, we can use the algebraic law of limit to apply the limit to both functions separately. Let's analyze the first limit. Limit n approaches infinity, negative 1 to the power n minus 1. As n approaches infinity, the value of this term can be positive or negative depending on the n value. For example, if we use a big n value, say 1000, the value of this expression, negative 1 to the power n minus 1, will be equal to 1000 minus 1, which is equal to negative 1 to the power 999, which is equal to negative 1. However, if we use the n value 1001, then the value of this expression will become positive 1. Because negative 1 to the power 1000 is equal to positive 1. So the value of this expression will keep switching between positive and negative values. The value of the limit for the polynomial function n will be infinity. Since the value of the limit for negative 1 to the power n minus 1 will flip between negative and positive values, the value of this overall limit will be in negative infinity or positive infinity. That means the limit for the given expression negative 1 to the power n minus 1 times n does not converge to a particular value. Therefore, the answer for this limit is does not exist. This is a very important concept we need to understand and memorize for this type of problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.